Okay, so this video is just knowing what number we're going to multiply an equation by to be able to use the elimination method. I'm going to kind of hopefully model your thinking. Alright? So for the first one, negative 5x minus 2y equals 6, and 3x plus 6y equals 6. If we added these two equations, we would get negative 2x and 4y. We did not eliminate a variable. If we subtracted these two equations, we would get negative 8x and negative 8y. Again, we did not eliminate any variable, right? We need to have coefficients that are the same or opposites to be able to eliminate a variable. So can I multiply negative 5 by something to get 3? Not really. Can I get 3 to be negative 5? Not really. Can I get 6 to be negative 2? Not really. But can I get negative 2 to be 6?
Yes.
Yes, I can. Now remember, ideally, we're looking to have a negative 6y and a positive 6y. Because then we can add the two equations to eliminate, right? I already have positive 6y in the denominator of this equation. So that means I want to have negative 6y in the numerator. In the top equation. So I'm going to take this top equation and I'm going to multiply it by 3. The reason it's positive 3 is because that's a negative 2y already. So what do I have to multiply negative 2y to get negative 6y? Positive 3. So I distribute to everything. Okay? So this becomes negative 15x minus 6y equals 18. And the bottom equation stays as 3x plus 6y equals 6. I now have a problem where I have coefficients that are opposites. If I were to add these two equations, I'd get negative 12x. The y's would cancel out, and it would equal 24. I can continue to solve for x is equal to negative 2, and it would be good. I'm not going to go over how to solve it right now. I just want to go to the next problem. I want to focus again on just multiplying these two equations. Again, the x's do not have the same or opposite coefficients. The y's do not have opposite or the same coefficients. But I can get the y's to have opposite coefficients. I'm not going to multiply 2 to get 7 or 7 to get 2. I'm not going to get 3 to be negative 1, but I can multiply negative 1 to be negative 3. I'm going to multiply this bottom equation by 3. The top equation has positive 3y. I can get this negative y to be a negative 3y by multiplying by positive 3. So, here we go. I multiply everything by positive 3. The top equation will stay as 7x plus 3y equals negative 1. The bottom equation will become negative 6x minus 3y equals negative 24. And again, I could add these two equations because the coefficients of y are opposites. 7x plus negative 6x is positive 1x. Positive 3y minus 3y, right? Those cancel out. And negative 1 plus negative 24 is negative 25. So x equals negative 25. Again, I can substitute back in and solve. When you substitute, make sure you're using the original equation.